Hi everyone, and in this ed puzzle we are going to do some review of stoichiometry as well as limiting reactants and determining those. So let's go ahead and start with this example. This is not a limiting reactant example, but this is a stoichiometry example. So we have this chemical reaction CH4 and 2O2 becoming CO2 and 2H2O. This is one that we see all the time, it's combustion. We begin the chemical reaction with 48 grams of CH4 and excess O2. What is the mass of CO2 you can produce? So we're starting with 48 grams of CH4, and we want to know the grams of CO2. This means we are going from mass to mass. So let's go ahead and start doing our setup. So 48 grams of CH4. What is the first thing that I'm going to do here? I'm going to first go ahead and use molar mass. And I want to make sure that I use the molar mass of CH4 so that I can cancel out my units. So the molar mass of CH4 is 16.04 grams of CH4 for every 1 mole of CH4. Remember, molar mass is the mass of 1 mole. Cancel out grams of CH4. And now we can keep going. What's going to be our next step here? Our next step is going to be a mole ratio because we have now gone from grams of CH4 to moles of CH4, and now we need to go to moles of CO2. What's going to be my mole ratio here? I'm going to get my mole ratio from the balanced chemical equation. So 1 mole CH4, 1 mole CO2. They're both just no number in front, so therefore they are going to just be 1. Cancel out my units again, mole CH4, mole CH4. And now I'm going to go on to my last step, which is going to take us to the mass of CO2. So we're going to use molar mass. 1 mole CO2, and the molar mass of CO2 is 44.01 grams of CO2. Again, just get the molar mass from the mass of C plus 2 times the mass of oxygen. Cancel out our units here, and all we have left to do now is to multiply. So we're going to do 48 times 44.01 divided by 16.04, and this is going to give us 131.7 grams of CO2. And that would be our answer. So if we started this chemical reaction with 48 grams of CH4, we would end this chemical reaction with 131.7 grams of CO2. Let's go ahead and start talking about limiting and excess reactants. So like I was talking about in class the other day, excess reactants are what is left over after a reaction ends. Limiting reactant is what runs out first. It's the reactant that will be used up, and once it is used up, the reaction cannot continue, no more product can be made. I'd used the example in class of making cheese sandwiches, and we ran out of bread, so bread was the limiting reactant. And then we couldn't make no more sandwiches after that. But we had cheese left over, which would be the excess reactant. So let's take a look at how we figure this out. So first of all, we have this chemical reaction. We first need to actually balance it. So let's go ahead and balance it really quick. We begin this chemical reaction with 5 moles of magnesium and 4 moles of AlCl3, which is the limiting reactant. The way that we determine a limiting reactant is we figure out how much product each of those amounts can make and then compare them. So we're going to start by doing 5 moles of Mg, and we're going to figure out how many moles of one of our products can be made. I'm going to pick Al just because, but you also could do this with MgCl2 as well. It does not really matter. So I'm going to use a mole ratio because I'm going to go from moles of magnesium to moles of aluminum. So taking a look at my chemical equation, I'm going to put 3 moles of Mg on the bottom and 2 moles of Al on the top. Go ahead and cancel out my units just like normal. Cancel those. And we can go ahead and multiply out. 5 times 2 divided by 3 gives us 10 divided by 3, 3.33 moles of Al. So that is the amount that can be made from our magnesium. Let's do the same thing now, but with our amount of AlCl3. So we have 4 moles AlCl3. We're going to do the exact same thing, and we still want to figure out how much aluminum can be made because we need to compare the same product. So I'm going to put 2 moles AlCl3 on the bottom and 2 moles Al on the top. Cancel out my units. And we can go ahead and multiply out. 4 times 2 divided by 2. It's just going to give us 4 moles of Al. So that's the amount that the AlCl3 can make. Based on these two amounts, I can then say that the limiting reactant is magnesium. The reason I can say that is because magnesium is only able to make 3.33 moles of aluminum. Aluminum chloride, AlCl3, is going to be the excess reactant. And that's because it can make 4 moles of Al. Magnesium can make the least amount, so that means that we are going to run out of magnesium. We will only end with 3.33 moles of aluminum. It's like the cheese sandwich example. We could only make as many sandwiches as the limiting reactant told us we could. So because we can only make 3.33 moles of Al with magnesium, magnesium is the limiting reactant, and this will be how much product we are able to make. Let's take a look at another limiting reactant example. This one, though, we're actually going to use grams, so starting with grams instead of moles. So our question here says, you begin with 20 grams of H2O and 75 grams of SO3, which is the limiting reactant. So I'm going to have you do some of this. So first things first, you need to do 20 grams of H2O and determine the moles of H2SO4. And I give you the molar mass of H2O right up here. I'm just going to really quick here show you how to do the stoichiometry for this. So we're starting with 20 grams of H2O, and we're going to use the molar mass first to go from grams of H2O to moles of H2O. Cancel out our units, and next thing we can use then is a mole ratio to get from moles of H2O to moles of H2SO4. Once you do that, multiply everything on the top, divide by everything on the bottom. Now that we know how much H2SO4 our amount of water can make, let's do the same thing for SO3. Again, I give you the molar mass right here. Again, I'm just going to really quickly here go through the stoichiometry with you. So same sort of thing, starting with grams of SO3, using molar mass to go to moles of SO3. Once you get there and cancel out your units, you can then just use a mole ratio to go from moles of SO3 to moles of H2SO4, multiply everything on the top, divide by everything on the bottom. Now we compare them. So we've figured out that the amount of water would make 1.11 moles of H2SO4. We found out that the amount of SO3 could make 0.94 moles of H2SO4. Based on these two amounts, which of the two reactants do you think is the limiting reactant? Based on these two amounts, our limiting reactant is going to be SO3. The reason being is it can make the least amount. So that means that it will run out before the H2O. Let's go ahead and do one more limiting reactant example. For this one here, first thing you need to do is actually balance your chemical reaction. So go ahead and do that. We begin this chemical reaction with 80 grams of potassium and 25 grams of H2O, which is the limiting reactant. For this question, we want to figure out if potassium or water is the limiting reactant. So for both of these, we are going to go from grams to moles of one of the products. I'm going to go ahead and choose KOH. But you could also do it with H2 and get the same exact result, just different numbers. I'm going to go ahead and have you do this first one here, so 80 grams of potassium. Go ahead and do the stoichiometry with that to get to moles of KOH, and the molar mass of potassium is 39.10 grams per mole. I'm going to go ahead and just really quickly here show you the stoichiometry for this. So you would start with grams of potassium, use the molar mass to go from grams of potassium to moles of potassium, then go from moles of potassium to moles of KOH using a mole ratio, multiply everything on the top, divide by everything on the bottom. So based on the amount of potassium that we have, we could make 2.05 moles of KOH. Let's go ahead and do the exact same thing now for the amount of water that they gave us, which is 25 grams of H2O, and the molar mass of H2O is 18.02 grams per mole. Again, real quick, here's the stoichiometry for this one. So going from grams to moles of water using the molar mass, then going from moles of water to moles of KOH because we want to use the same product to compare using a mole ratio. Multiply top, divide by bottom. Based on these two amounts, which is our limiting reactant, potassium or water? In this case, it would be water because it was able to make less of a product. We would run out of water first. Make sure you also did the CK12 practice, and if you have any more questions about this, we will be doing more practice in class on Thursday. Have a good one.